Yes, student, I come here for velocity center mass. We have obtained in last video the coordinates of center mass and position vector of center mass, etc. Again, from figure, if mass m1, m2 are there, and f1 and f2 are the action force acting on mass m1 and m2, then we can write total force on system in F1 plus F2. If M1 plus M2 equal to M, coming, and from Newton's second law of motion, where M is supposed to be a center mass, vector F equal to, can be written as dp over dt, and F1 and equal to d upon dt of P1 equal, or F2 equal to d upon dt of P2. K momentum current time equal to force, but P equal to mv, but P is equal to mv, therefore vector F can also be written here as equal to d upon dt of nVcm, and F1 as d upon dt of m1v1, and F2 d upon dt of m2v2, where v1, v2 are the velocity at an instant of time of mass m1, m2. Here, where m is found, where Vcm is the velocity of central mass, V1 and V2 are the velocities of masses M1 and M2 respectively. So d upon dt of mVcm equal to d upon dt of mv1 plus d upon dt of mv1 v2 and v2. Or you can write as d upon dt of m1 v1 plus m2 v2. Now comparing the two sides, you will get here mVcm equal to m1 v1 plus m2 v2, and therefore Vcm equal to m1 v1 plus m2 v2 upon capital M. Now what is capital M? Sum of two masses or VCM is equal to M1 V1 plus M2 V2 upon M1 plus M. This we have derived for a system of two particles only. Now we can generalize this equation for n particle system. This equation can be generalized for n particle system. That is VCM equal to M1 V1 plus M2 V2 plus M3 V3 so on up to plus Mn Vn upon M1 plus M2 plus M3 plus 1 up to plus Mn. Or simply we can write this equation as VCM is equal to summation Mi Vi upon summation Mi. Here I varies from 1 to n. Sometimes we write, sometimes we don't write. So this is the concept of velocity of center mass. Now we have learnt in last chapter momentum, product of mass and velocity, and then law of conservation of momentum. Law of conservation of momentum. And velocity of center of mass. What is the relation? Actually, law of momentum states that momentum of body or submomentum of body remains constant in the absence of unbalanced external force. I can write here if a system is made up of n particles of masses M1, M2, M3, so on up to Mn, whose masses are whose velocities are V1, V2, V3, so on up to Vn. If capital F be the external force acting on the system, Then what can you write? Q vector F is equal to d upon dt of m1 v1 plus m2 v2 plus m3 v3 plus so on up to mn vn. If velocity of center mass VCM V, the velocity of center mass, then MVCM equal to M1 V1 plus M2 V2 on up to ML Vn. Capital M is the total mass system. Capital M is the total mass of the system, and therefore vector F is equal to, this is external force, d upon dt of MVCM. Now, if F is equal to 0, then d upon dt of MVCM equal to 0, and hence MVCM equal to constant, and therefore since mass system does not change here to VCM, and hence VCM is constant. What does it mean? That velocity of center mass does not change if no unbalanced external force act on the system. If system experience no unbalanced external force, then velocity of center mass does not change, whatever be the changes of momentum of individual particles, but overall velocity of center mass will not change. So this was all about coordinate center mass and velocity center mass. Now I want to explain you one question so that you may understand what I have taught till now. Actually there is a question here, a simple question. There is a square frame each side A. Here is placed mass M. It is 2m here. It is 3m here. It is 4m here. So here you are asked with the center mass. Find the center mass of given system shown in figure. Right. So how to find out each side A? We assume that mass M placed at origin of coordinate axis, x-axis and this be y-axis. The solution is like that. Let mass small m is at origin. Since each side A, so coordinates of mass m 0 0, 2m, a by 0, 3m, a by a and a, and 4m, 0 by a. इनके यहाँ 0 0 कोऑर्डिनेट्स, यहाँ a and 0, it is a and a, it is 0 and a. We assume here, we have assumed that mass m plays at origin, and so now we know x is equal to summation mi xi upon, so x coordinate of central mass m1 m है a1 0 plus m2 2m into a plus 3m into a plus 4m into 0 upon total mass m plus 2m plus 3m plus 4m. It comes here 0, this 0, 2 plus 3, 5. 5m upon, this is 10m. So it is a by 2. X coordinate of central mass is a by 2. Now what is y coordinate? Y is equal to m1 m 0 plus 2m उसका भी 0 into 0 plus 3m into a plus 4m into a. Y coordinate है upon 10m, and that way it comes out to be 7a, 7m upon 10m. So y equal to 7a by 10. तो कहाँ होगा सेंट्रल मास? Where is central mass? This distance a by 2 here. This distance a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you start 1, 2, 3, 4, 5, 6, 7 like this. So it will lie here cm at position a by 2, where 7a by 10. So that way you can locate the central mass of this type of system. There are many questions based on this, and people ask very frequently in different exams. I will be telling you more numericals, but I hope you have got this idea of finding the central mass. In next coming videos, first I will give you more numericals, and you can search, and please do yourself. Write in your copy the solution. Don't think that you have read and you have got it and you can do it very frequently. No, that is not possible. Thank you.